So here is our last exercise 1.4. It says that without actually performing long division, state whether the following rational number will have a terminating decimal expansion or non-terminating decimal expansion. It's a very simple and easy question. The question is asked that we have to perform the shortcut way. Means it is asked not to do the long division method. Without long division, you have to decide whether it is a terminating decimal or non-terminating decimal. So to solve this question, we have a theorem very nicely prescribed in NCERT, Theorem 1.6. What does this theorem say? If any denominator is expressed in the form of 2 to the power n or 5 to the power n. Example, let me write it for you and make you understand. The theorem says that let x equal to p by. So here the theorem 1.6. What does this theorem says? This theorem says that let x equal to p by q, which is a rational number, such that the prime factorization of q, if you factorize q, the denominator, if it is in the form of 2 to the power n and 5 to the power m, means if it is in the form of 2 to the power m or 5 to the power m, where n and m are some negative integer, then x has a decimal expansion which terminates. Then what we can say, that x is a decimal expansion which is terminating decimals. For example, let me carry out with this question number 1, that is 1. So what it is said, 13 by 3125. Let me factorize 3125. What you will going to get? 3125. So as you know, 3, 1, 4, 4, 5, 6. No, it cannot be divided by 3. So 5 is the factor. 5 6 are 30. 5 6 are 30. 5 2 are 10. 525. 5 1 are 5. 5 2 are 10. 525. 5 2 are 10. 525. 5 5 are 25. You can see the factorization of 3125 is 5 5 5 5 5. That means we can write 13 by 3125 as 5 q over 5. That means 5 5. There is 5 5. 1 2 3 4 5, which can be also written as 13 by 5 q over 5. As you can see, the denominator is in the form of 5 q over m. There is a factor, means there is the prime factorization of this is only 5. And you may be asked, what about 2? Sir, there is not 2. Where is 2? There is also 2. But the power is what? But the power is 0. Power is 0. There is 2, but the power is 0. And we know that 2 to the power 0 is what? 1. 2 to the power 0 is what? 1. So we do not write it. It means 1. So 5 q over m. Here the denominator is expressed in the form in the multiple of 5. That means what? The 5 is present. Then we can say that this decimal expansion will be what? Terminating decimal. Therefore it is a terminating decimal expansion. Therefore we can say it is a terminating decimal expansion. I hope it is clear. I hope it is very clear. So here you can see the next part of this question, 17 by 8. So if you factorize 8, the denominator, what you will going to get? 2 4 is 8, 2 2 is 4. That means 17 by 8. This 8 can be expressed in the form of 2q over 3. So here we can say that it is an terminating decimal expansion because the denominator is what? 2. So just remember that if the denominator is either 2 or either 5 or 2 and 5, if the denominator is only 2 or 5 or 2 and 5, then we can clearly state that the decimal expansion of this fraction will be what? Terminating decimal expansion. I hope it is very clear. That means it has what you can write, it has whatever, it has terminating decimal expansion. Terminating decimal expansion. Just remember this one. So let us carry to the next part. That is your 64 by 455. 64 by the next part. 64 by 455. So let us see. Firstly, let us factorize it. Let us find the factors of 455. 455. The first factor will be 5. 5 9 is 45. 5 9 is 45. 1 is 5. And the next factor will be 7. 7 1 is 7. 7 3 is 21. 7 1 is 7. 7 3 21. That means 644 can be expressed as 5 into 7 into 3, 13. So we can clearly say that it is non-terminating decimal expansion because the denominator cannot be expressed in the form of 2q over m, 5q over m. 2 and 5 are not present. Along with 5, other numbers are also present. So we can say that it is not a terminating decimal expansion. Therefore, it is not a terminating decimal expansion. I hope it is clear. Very simple, isn't it? Very simple. Now let us go to the next point, the next question. That is what? 15 by 1600. The next question is what? Number 3. 15 by 1600. So let us factorize 1600. What we are going to get? by 1600. So if we factorize the denominator here, 1600, 2800, 2400, 2200, 2100, 250, 225 and 55. Yeah, you can see only 2 and 5 are present. So we can clearly state that it is a terminating decimal expansion. That means 15 by 1600 can be written as 2q over 1, 2, 3, 4, 5, 6. 2q over 6 cross 5 square. 5q over 2. 2q over 6. 1, 2, 3, 4, 5, 6. So you can clearly say that it is in terminating decimal expansion because the denominator is expressed in the form of 2q over m and 5q over m. So therefore, it has terminating decimal expansion. Decimal expansion. I hope it is very clear, crystal clear. Let us move to the next question. This question number 5. 29 by 343. 29 by 343. So let us factorize it. 343. So it is factors of 7. 7 for the 28. 27 9 is 63. And 7 7 is 49. So we can write here 29 by 7 to the power 3. So absolutely it is not a terminating decimal expansion. It is a non-terminating decimal expansion because the denominator cannot be expressed in the form of 2q over m and m q over m. Therefore it is not. Yeah, you can write it has not terminating decimal expansion. Similarly, let us proceed to the next part, number 6. So write it. Question number 6. There is what? 23 by 2 to the power 3 5 over 2. Definitely, it's so clearly given here. It so clearly stated here. We don't have to factorize it also. So again, by looking at the question, we can say it is a terminating decimal expansion. Obviously, because the denominator is an expression in the form of what? 2q over n into 5q over m. Okay. Therefore, it has terminating decimal expansion. I hope it is crystal clear. Very good. Let us proceed to the next quote. Question number 6. So this is our next question number 6. It is given here like that. Question number 7. 129 by 2 to the power 5 to 5 to the power 7 and 7 to the power 5. So by looking at the question, we can say it is a non-terminating decimal expansion, because along with 2 and 5, the 7 is also present, and so we can say that it is not a terminating decimal expansion. Therefore, it is not a terminating decimal expansion. Clear? Crystal clear? Very good. Now question number 8. What is given here? 6 by 15. How can you write 15 as 3 5 ja 15? So 6 by 3 into 5. So along with 5 other numbers present, that is 3 present. So it has no terminating decimal expansion. So it is not, we can write, yeah, for it has not terminating decimal expansion. I hope it is clear. Now question number 8, 9. 35 by 50. 35 by 50. So if you go on expressing it in a factorized form, 50, 2 25 ja and 5 5 ja. So you can write 35 by 50. 35 50 can be written as 2 into 44 2. Therefore we can see it has only 2 and 5. So it can be expressed. So it has terminating decimal expansion. I hope it's clear. The last part is left, that is your 77 by 210. 77 by 210. 77 by 210. I can see that. So let us factorize it. 210. 2105. Now it can be divisible 3. 3 3 is 9, 3 5 is 15, 5 7 ja. Are bhai, it is not a terminating decimal. So 77 by 2 into 3 into 5 into 7. So you can clearly state that it is not a terminating decimal, because along with 2 and 5 other numbers are also present. That is 3 and 7 are also present. So which is not violating the theorem's 1 point theory. Therefore it has not terminating decimal. Terminating decimals. I hope it is clear.